Hello there. Hope you're having a great time. Welcome back to another session on Internet Web Programming. In this session, we're going to take a look at XML, Extensible Markup Language. We'll start off with understanding what is XML, why we use it. We'll take a look at a sample XML file, and then we'll move on to XML schema. What is the use of XML schema and how to validate a document using XML schema? And then we'll understand XPath. XPath is used for navigating an XML document. We will see how to use XPath for navigating an XML document. And then we will understand XSLT, XML style sheet transformations, wherein we'll take an XML file, transform it into an HTML page. And we'll also see the various clauses of XSLT, which will be useful for us in transforming an XML file to an HTML page. So we're going to take a look at all these things. It's going to be a quick look on all these concepts. Let's start off with an introduction to XML. Why we need XML? XML is Extensible Markup Language. We all know HTML. HTML, we know the tags, right? For instance, H2 is an element, and we have, say, Satish CJ is always boring. So something like that, and you close this tag H2. So what is this? This is an HTML element, and it defines how this text should be rendered on the browser. Say when I say H2, then we'll have a font size, it'll be looking bold and things like that. Likewise, when it says it's a paragraph element, it defines how that specific text should be rendered on the browser. So this is with respect to displaying the text. Whereas when you talk about XML, XML contains tags. So I'll give an example here. For instance, when we are talking about a project, we can start the tag and we can close the tag. And we can also have some sub elements here like project name. So for every tag, we'll also have a closing tag, project name. We'll close it and then say project name is, we'll call this project to be IWP. So this is the text. Now the difference between HTML and XML is in XML, the tags actually give some meaning for the text here. It defines what is the text that is between the tags. Say when I say IWP, what it means, it's a project name. So there is some meaning that is we derive some meaning for this text from the tags. So in HTML, the tags used to tell us how the text will be displayed, whereas in XML, the tags tell us what the text is all about. It adds some semantic meaning. That's what we understand here. When I say IWP, what is it? It is a project name. So in XML, we have a root element, and the elements will be nested. And also we have a closing tag for every element. So these are mandatory. And what is the use of a document like this? Why we need this first of all? That is the next question. The need for XML is it is used for data storage, data transfer. So you can transfer data between systems in XML format, and it's used for creating layouts, formatting documents. So there's a lot of use of XML as a data format. So first we'll see how XML is used in data transfer. So let's go to a new slide, or let me go to a white screen here. Let me explain you what is the use of XML from the data transfer perspective. Say you have two systems and let's say two servers, they are in need of communication. They want to communicate between each other, and there should be some data transfer happening. So there should be some data that should be sent to this server, and the data should be retrieved by the server, process the data, maybe display it to the user or move it to a database, something like that. Likewise, data can be sent from this server to this server, and this server can process the data and move it to the database, perform some computation. So there is a need for a data exchange between systems which doesn't involve human intervention. So in that case, we need some structure for the data. Like we have to define what kind of data and the structure, the way data should be transferred between systems. So in that case, we go with XML. What is XML? Extensible Markup Language. And we define data in XML and then we send it across so that this system will be able to retrieve the data and process it. So what XML contains? It contains some tags, opening tags and closing tags. So you have some opening tags and closing tags like HTML, but the point here is these tags define what the data that's coming in. So we have seen what is the use of XML and what you can expect inside an XML file. I will show you a sample XML file now. So let's go to this sample XML file. So this file is about a project database. So it contains data about projects in an organization, let's say. So this is the root element. Project database is the root element. Every document has a root element. And whenever you have an element, you also close that element. Say this is the closing element for this element we have opened. And project database contains projects. So here there is a data about 2 projects. So again, when we are talking about a project, project is nested within project database. Say there is nesting of elements here, root element, and project is a child of project database. And project database has got 2 projects here. So we can say project is a child of project database. And when you open a project node, you should also close it. And project has got many elements, sub elements defining it. For instance, a project will have project name, project domain, budget. So all these 3 elements are defining the project element. It means that project, when you talk about project as such, project has got many elements defining it. So you can say project is a complex type. Project is of complex type. Why we say project is an element which is having sub elements defining it. So we say project is of complex type. Whereas when you take a look at project name we say that's a simple element. Why we say it's a simple element? Project name is not having sub elements defining it, right? So project name is one single element and you don't have sub elements for that. So we can say project name to be of simple type, whereas project to be of complex type. And we also have some data types associated with these elements. Like for instance, when you talk about project name, it will be a string, right? And when you talk about project domain, it will be a string. Whereas here project budget, we can think of budget to be an integer. So normally when data for projects repeat, we expect the same convention, that is the same order. What is that order? First I expect project name, next project domain, and next budget. So there is a sequence. What do you mean by a sequence here? Project name comes first, next domain, next budget. So for every project, there should be the sequence followed. That is, you have project name, project domain, and project budget. Likewise, for every project node, the data types also should be the same. For instance, project name should be a string, project domain should be a string, budget should be an integer. So these are the expectations. Say if this file is sent from one of these systems to another system, so if this system is going to process that file, it will be expecting that file in this structure. So it's going to expect the details of projects in a sequence, and project is a complex type, and project name, project domain, budget is of a simple type. And also we have some data types associated with these elements here. The next important thing is every element, when it is open, it should also have a closing tag, and any open tag should also have a closing tag. That is important. And element names should not contain any spaces. You can't define an element like this, project space name. That's not allowed. You can't have a space between elements. And we have some normal naming conventions for elements like you have in any element, like the element names are actually case sensitive. Say project name is different from everything you give in caps, right? Project name. So this capital letter project name is different from this project name. So elements or actually the tag names are actually case sensitive. Tag names should not contain spaces. And there's one more thing. You can also have attributes for a project. Say for instance, there's a project, you can have an attribute for it. Like for instance, I can say project branch. I not mentioned that here, but I'll write it. Branch is equal to engineering. What is it? It is an attribute, so it will be next to that project, and then you'll say branch equals to engineering. Maybe this project branch is equal to some finance or something like that. What is that we understand here is for HTML we had attributes for elements, right? Likewise for project 2 we can have attributes. Can you think of HTML element attributes? Any HTML element attributes? I'll write it here on the top. For instance, if you have an H2 element, what kind of attributes you can think of? Class is an attribute, ID is an attribute. So you give class equal to ID equal to, and then you close it, right? The same way, an element here in XML can also have attributes like this. That is possible. So these are something, these are some rules that we have to follow while we are creating an XML file. And XML element names should start with a letter or an underscore, but it should not start with a number or any special character like that. And XML element names, I mean the element name should not start with the word XML. That is also not allowed. So these are some of the things that you should take care of. Whereas the elements can contain hyphens and underscore, a special character, but it should not start with a digit. It should start with an letter or an underscore. So element name should always start with a letter or an underscore. I hope you have now got a clear idea about what an XML file looks like. What an XML file looks like, it has got an root element and it has got sub elements, and there's a proper nesting. Every element that has open tag should also have a corresponding closing tag. Element names cannot contain spaces. Element name should not start with a digit or any special character. It should start with only a character or an underscore. That is important. And element name cannot contain spaces. And you can have attributes for elements. And there is a sequence. That is, if they occur in an order, they should be in that order while we are receiving it. For instance, here we have project name, next project domain, and budget. And then we also talked about complex type. What is a complex type? An element containing sub-elements, that becomes a complex type. What is a simple type? There's no sub-elements defining that element. So project is of complex type, whereas project name is of simple type. And this order is called sequence. So let's go to the next concept, that is XML schema. So what is the use of XML schema? We have already learned database schema, right? What is database schema? Let me just go to a white screen. Say database schema. We say we have some data for student table. Let's say a student name. I'll put my name here, Satish. Student ID, some registration number 12BC002, and marks is code in IWP, say 12 marks. Like that, we'll put some data here. Address, Vellore. So this is the data. But when you want to store this inside a table, we define a schema. What is the schema? The schema contains, say, name. We say what is that we are expecting. First field is the name. And then we can say it's varchar 20. So what is that we define here? Name should be of character and the size is 20 characters max. Likewise, the next field we are expecting is registration number. And say it is a fixed length character of 10 digits or 10 characters. Next, marks. Marks can be of int. It's an integer value that we are expecting here. And address, again we can define address to be of say variable length character of 15 or so. So what is that we define by this schema? Why we need this schema? What is the use of this database schema? When the user tries to insert a record, that record will be validated against the schema, whether name is of characters, whether it is less than or equal to 20, whether registration number is of fixed length character, less than or equal to 10, and marks whether it is of integer type, that validation will happen, whether the address is of type varchar and it's less than or equal to 15 characters in length. So this validation happens, right? Every time you insert a record, if this data is not matching the schema, then what happens? You get some constraint violations, some exceptions you are going to get. The data is not going to be inserted. So this is the use of the database schema. The same way, what we have is an XML schema. What is an XML schema? You are getting this beautiful XML file from another system, and it has got some tags, some data in it. Now we should have a schema associated with it, XML schema. What is this XML schema all about? It will tell us what is the element that's expecting, say whether that element is a complex type. So it will just define us, okay, what is the element and what is the data type for the element, and whether this element is a complex type. If it's a complex type, what are the sub elements we are expecting, and what is the data type for all these sub elements, and do you have any restrictions on the data that should be coming in for elements. Likewise, so you're going to have a definition for the file. So this schema will give us some idea. It tells us, okay, this is what we are expecting from a file that's coming in. And this schema will be used for validating this XML file. The same way like you think of a database schema validating an input record. You get the file, we'll take it and validate against the schema. Okay, is the first element there, and is this element of type integer? Do you have that element to be of type integer? And there is a sequence of elements here. Is that sequence followed in the XML file? So there will be a validation happening using this XML file that's coming in. So XML schema is used for validating. It's used for validation of an XML file. Why we need to validate an XML file? Only then that file is a valid file. It will not give us any issues. Say if there is a file, if there is an XML file and we expect project name, project domain and budget to be in the sequence. But what we receive actually is project name and budget and domain. There is a reversal of the sequence. Then how will you find this? When you validate it against an XML schema, you will come to know there is an issue, and then we can say the file is invalid. So what is the use of XML schema? It defines the structure of an XML file. It's like, you can think of it like an DB schema, which you have already learned. So we are using the schema for validating. So enough of this theory. Let's go to the file. Let's check what is the XML schema for a project database, which we have just now looked at. So what is the project database we have looked at? Let me erase all the ink on the slide. So this is the project database file. For this, if you want to generate an XML schema, how it looks like. So we say XS element name. Here XS is nothing but the default namespace. So this is the namespace. So every element will be tagged with this namespace called XS. So it's a default namespace. Let's say the first element we are expecting is project database. And what is project database? It is a simple element or a complex element. Project database has got multiple sub elements, right? So project database is of complex type. So that's what is given in the schema. So we say it is a complex type, and we expect things to be in a sequence. So that is XS sequence. And the next element that comes inside the project database is we have a project element. Max occurs unbounded is you can have any number of project nodes within project database. That is the meaning. And is project complex type or simple type? Project is a complex type because we have many elements defining project element. And is there a sequence associated with project? Yes. We always expect project name, project domain, budget should be in a sequence. So we say it is XS sequence. XS complex type, XS sequence. So these two things define the project. And we also talk about the data type here. Say we expect project name, project domain, budget in a sequence. And we also mention the type. Type is string and project domain is string. Here budget, we have mentioned it as string, but it can also be an integer. Say these are the data types we can mention in our schema. So we have string, integer, decimal, date, time, boolean. So you want to have project budget to be integer, you can just say XS integer. So you're defining the schema for the file here. And whenever you open an element, say whether it is complex type or sequence, you should also close it. That's it. So we are closing all the elements in the order we have opened it, and that's it. We have defined the XML schema for our project file. Are you able to understand what this schema actually tells us? It tells us you have an element that's project database, it's of complex type, and we expect a sequence of projects. And next comes the element project. There can be any number of projects. It's unbounded. And it's also complex, and we expect the elements, sub-elements to be in a sequence under the project. And we define some data types. Okay, we want project name to be string, project domain to be string, and budget to be a string. And we close all the tags. So whenever a project node comes in, it should be satisfying these requirements, and a project database should be satisfying these requirements. So we have our XML schema, and what is this schema associated with? This schema is for this particular file which we are planning to receive from another system. So for this file, what is the schema file? This is the schema file. We can also go ahead with more restrictions to our file. For instance, you want the budget to be within a specific range, say minimum budget and maximum budget, and we can also define this to be of a type integer. So we can give some more restrictions to our file. Let me tell you how to give these restrictions. Say for instance, element name is budget. Under that I can add that is of simple type. What is simple type? Element name to be of budget. And the restriction we are giving here is this budget should be of type integer. Minimum value is 5,000 and maximum value is 80,000. So whenever you're getting an XML file with a project budget in it, you should get it within the range, either it's between 5,000 and 80,000, and the value should be an integer. So you can mention a restriction, min inclusive and max inclusive value is equal to whatever value, that is the range we can give. So we can add restrictions to our project. Where we can add this? So on budget, we can put up a restriction that this is the minimum value, that is the maximum value. Not only for integer values, even for strings, we can put some set of values that it can take. Say when I talk about project domain, it's of simple type, and what project domain, what values can project domain take is, I'll give it as enumeration value, PHP, ASP, JSP, and it should be of type string. So what is that we say by having this in our XML schema is, whenever I get my XML file, the project domain attribute, which is a simple attribute, should be of type string, and it should be taking the values either PHP, ASP, JSP. If you get a file with any other project domain, then we say it's an invalid file. Okay. So restrictions we can always add to our XML schema. These are like add-ons to the schema. We have seen the schema wherein we didn't have any restrictions, so we can have restrictions to an schema. That's what we are seeing here. And there are more things like default and fixed value attributes. See, we can also mention some value to be default. Say if there is no value coming for this element, then the default value will be red. By default, assign the value red for that element if the element is not assigned a value. What is fixed? For an element, the value, if it's not there, it's going to be assigned a fixed value en. That's what is given here. So when it is fixed, you can't assign any other value other than the value that's given here. So that is fixed. Default is when the element is not having a value, by default red will be assigned. Whereas when it is fixed, you can't assign any other value other than what is given as fixed. So you can also define what is default and fixed. You also have optional and required. So what is optional? By default, every element is considered to be optional. It may be or it may not be. But if you want that to be required, you have to say use is equal to required. So it means that that specific attribute or element is going to be required. It's mandatory for it to be present in the file. By default, an element is optional. Say it can be in the file or cannot be in the file. Likewise, an attribute is also optional. But you want that to be mandatorily present for a specific element. What you should say? Required. It's like required in HTML, right? When you give required, it's mandatory for the user to enter the input. The same way, when you say it's required, the element should be present in the file. So validating an XML document. So we have our XML file, which we call it as a project database. We have created the XML schema, which is the schema which we have generated. So we can check whether this XML file is a valid file by validating it against. So we can validate this against an XML schema. For this, I am using an online tool. So we'll go to this tool, we'll check, and even before going to this tool, we'll see how to code an XML file in VS Code. So here is this XML file, and as I told you, so you have this project database, that's the first element, and we have the project node and the project sub elements and another project node, and we close the project database. So when you're coding an XML file using VS Code, you just create a file and call it say filename.xml. And when you open a tag and you want to close it, for instance, if I create another project node, see there is an automatic close of tags here. If you want to have these things, what you can do is you can go ahead and install this extension. That is, this is the extension I have installed, XML support, XML language support by Red Hat. So I've installed this extension. What is the use of this extension is it will create an XML schema for your XML file. Automatic generation is possible. So let me show you that too. Let me delete this. So initially, when there is no XML schema for your file, you're not going to have all these things. Let me save. So this is how your file is going to be. A simple XML file, and you want to generate XML schema. I'll tell you that schema will be generated as .xsd file, project.xsd. First, I'll delete this file and show you how to generate this from an XML file. So this file is deleted now. So I have just my project database XML file. For this, I want to generate a schema. So how I can generate this schema? So you see here, generate project.xsd. When I click on it, and my project.xsd, the XSD is the schema. When I click on the XSD, you see the schema is generated. So in VS Code, there's no need for us to write the schema. You can just generate the schema like that. So for this project.xml, we have project.xsd, and you can see it creates the schema. Project database is the element of complex type, and it follows a sequence. Likewise, project, max, success, unbounded. So we have seen what this schema means, right? So we have a schema, we have an XML file. And after you create the schema, you see there is an automatic binding for this XML file. What is the schema? Project.xsd is the schema. So let's validate whether XML file is a valid file by using an online tool. So we'll copy our XML file, and then we'll go to this tool, and we'll paste the XML file. Next, we should paste our XML schema. So this is our XML schema. So let's paste this XML schema here. And we'll click on validate XML. You see the XML document is valid. Only when we are getting the XML file as per the XML schema, we'll get this output. XML document is valid. Once when the XML document is valid, you can go in for further processing of the document. I hope you are clear with the concepts on XML file structure and its rules. And then what is the use of XML schema and how you validate an XML file against an XML schema. Now let us take a look at this concept XSLT, Extensible Style Sheet Transformation. What is this? Why we need this? See, when you open an XML file, say you are receiving an XML file from another system and you want to display this file to your users. And what happens when you open an XML file directly on the browser? This is what you're going to see. And people will not know what these tags are and why we have this. People are interested only in the data. You should present the data in a better way for people to understand, right? You can't just throw a file like this. So what is that we need actually is we should take our XML file. Maybe it contains all the project info. We should throw it as an HTML page. So what is an HTML page? We are having an HTML table here and some headers. Now you have your project data, project name, domain and budget. So this is presented as an HTML table. Not only that, what we are performing here is from the XML document, we are extracting. So we are extracting what we are extracting? We are extracting the project name, domain, budget. We are placing that inside an HTML table. So XSLT, Extensible Style Sheet Transformation, is all about transforming your HTML document to, it's all about transforming your XML document to another document. It can be a PDF, it can be an HTML document, so it can be any other document. So XSLT is used for taking an XML document and transforming it to other formats. Here we'll be focused only on HTML. So we are taking our XML document, transforming it to an HTML document. And when you're performing this transformation, what is important is you should navigate through your XML document and you should get this data, right? You should get where project name is, where domain is, where budget is from your XML document. And then you have to insert that inside an HTML table. So only when you're able to fetch the data, you'll be able to insert it in an HTML table. So this is very important. We should be able to navigate our HTML or XML document. Should navigate the XML document. We should know where project name is, where domain is, where budget is. And then we should extract it and we should insert that in HTML. So all these things come under XSLT, that is navigation, extraction, and then inserting inside the HTML table. So for navigation of an XML document, we use XPath. So we'll learn what is XPath, why we should know this, because this will be used in XSLT, that is we will be navigating our XML document, extracting the info, and then inserting it into an HTML. So this is XSLT. So navigation of XML document, we'll use XPath. So XPath will be used in XSLT. And what is the use of XSLT? Finally, we'll be able to get an output in HTML like this by using XSLT. So let me repeat this if you're not clear about what is XSLT, Extensible Style Sheet Transformation. What is the use of this? You take an XML document, you transform it to another format. It can be an HTML document or a PDF document. And what you do in an XSLT, we navigate through our XML document, get all the node data we need, say like project name, domain, budget for every project in our scenario. And then we will insert that in the specific places on the HTML table so that we get an output in the form of an HTML page. So for navigation in XSLT, we are going to use another concept called XPath. What is the use of XPath? Navigation of an HTML document. So first we'll understand XPath, then we'll use XPath in XSLT to transform our documents. Let's take a look at XPath. So XPath is used for navigating an XML file. So what is the file we have? We have our project database file. And how will you navigate? Say slash represents the entire document as an object. So it returns entire document, XML document as an object. Slash root node. Say when I say slash project database, so it returns all the project nodes under the project database. So that's how you navigate. So when I say slash project database slash project name, I'll be able to get the first project name in the document. I'll be able to navigate to the first project name. When I give double slash project, it means I'll start with a project node in the document. The very first project node in the document, I'll start and I'll scan all the project nodes. Dot represents the current node I am in. Dot selects the parent node of the current node, and double slash at attribute. So here attribute is branch is equal to engineering, we have seen, right? So we'll be able to select all attributes of a specific name, say branch, from the document. So I have this online XPath tester, which we'll use for testing our XPath commands. So we'll go to this tool. We'll just run some XPath commands quickly. So this is the XPath tester. I've already pasted my XML document here. Say I'll run some XPath expressions. The first thing is when I give a slash, you see this is the entire document is returned as an object. If I want to get all the project nodes within my project database, I'll just give the root node here, project underscore database. So it fetches me the entire document, right? All the project nodes under project database. If I'm focused on getting the project name, how will I get that? So it's slash project name. So you see it fetches me the two project names for the two projects. So this is the project name and this is the project name. So if I am focused on getting only the project domain, what I should be giving? Project domain. So this is PHP and this is ASP. So this is a project domain and this is a project domain. So by using XPath expressions, what is that we understand is we can navigate through the XML document. Say if I just give double slash project, what it means, it's going to start with a project node and then it's going to fetch all the project nodes alone. So only project nodes will be retrieved, and you see it started with this project node and then it retrieved all the project nodes. And you can also go with predicates. Say for instance, if I want to find all the projects with the branch engineering, say I just want to give branch engineering here. Branch is equal to engineering. So this is an attribute we are giving. Say if you want to search for projects with an attribute branch, we can give at branch. So what is that attribute we have for branch? That is engineering. You understood? So we are able to locate an attribute by just giving double slash at branch. We also have some predicates. For instance, if I want to find the data of the first project node, I can give project database. That is the root node, and project. Say it returns both the project nodes now. If I'm focused only on the first project node, I can just give a 1 in parenthesis. So I'll be able to traverse to the first project node. If I want to traverse to the last project node, I can just give last, and that fetches me the last project node, that is attendance management system. So we are only in the last project node here. So there are a lot of XPath expressions that you can write, and you can test it using this online tool. It's pretty easy. Say I'm just focused on title at attribute. Say bring me all the projects with the attribute branch is equal to engineering, or bring me all the projects with the title branch. So how we perform that? Say bring me all the projects. What is that we do? With the title branch. So it's like at branch. I think it's at branch. Yeah. So we have to give that in parenthesis. I forgot that. I'm sorry. So it's like bring me all the projects which has this branch as an attribute. So we have only one project which is having the branch attribute. So we were able to fetch that. If you are very specific about bring the projects wherein the branch attribute as the value engineering, then you have to go with a definition like this: at branch is equal to engineering. So let me run this one too. So at branch is equal to engineering. So we should have this parenthesis closed here. So you can also search for a node using the attribute. That's what we are seeing here. So you can really master XPath expressions, but due to time constraint, we will stop at this point. That is, what is that we know? We can navigate an XML document using XPath expressions. So when I give slash project database root element, I'll be able to get the entire document with all the nodes. If I give slash database slash project, I'll be able to get only the project nodes under the project database. If I give slash project budget, say if I give budget, I'll be able to retrieve all the budget for all the project nodes within that file. So XPath is very effectively used for navigating an XML file. Now we'll take a look at XSLT. We'll be using these expressions in XSLT. I don't want you to forget these things. So just have in mind, and we'll be applying that in XSLT now. Yeah, it's a lot of concepts. As I told you, it's just a quick overlook of all these concepts, and maybe will help you from your examination point of view. But you can spend more time, look at all these concepts. When you understand what the actual use of these concepts are, you can spend more time and explore further. But now we'll take a look at XSLT clauses and certain exercises in XSLT. Now we are moving on to XSLT, that is extensible style sheet transformation. We will take an XML document and transform it to an HTML page. The first thing is this is our XML file, and for this XML file, what is that we are going to create is project.xsl file. So this is the extensible style sheet file. So we have to create this, and this will be referenced in our XML file. So for this file, this is the .xsl file. So we have an href here. So there is a binding between our XML file and our XSL file. This is the style sheet. Why there is a binding? When I view my XML file on a browser, this XSL will be used for displaying that file. So we are just going to view project.xml. Say project.xml. What is project.xml? Project.xml is this file. This file is binded to an XSL file. This is a style sheet file, which will enable the transformation of this XML file to an HTML file. So when I view XML file, since I have bounded this XSL file, I'll be able to view the document as an HTML file output. So what is the output we are expecting here is, our output will be like this. That is, the first thing is, we will take the employee management system, that is the project name, project domain, project budget for the first project node alone, and then we will display that as an HTML table. So for displaying this, we should create this XSL file. I told you, right? What is that XSL file we have to create? Project.xsl. And this is the source code for XSL file. And what is there in this file? It's very simple. You start with this standard template match, and here is our XPath. So we are going to go through all the nodes in our project database file. So this says this is the root node slash project database. This is the XPath expression. And inside this XSL file, we are going to give the HTML code. So we are displaying the entire XML file as HTML, right? So we are writing this HTML. So body, J component project list is the H2 tag, and background color is yellow for the header, that is project name, domain, and budget. See, our output should contain an HTML table. So project name, domain, and budget will be the th, and it's an header row, and the background color is yellow. That's what is given in the XSL file. The first thing is the HTML table code, and within that row, say next comes the data row. In the data row, what is that we should display? We should display the project name, domain, and budget. This we should extract from our XML file. Where is the XML file? So this is the XML file. We should extract project name, project domain, and budget. How you do that is we use XPath expressions. So there are two things. One is the XSLT clause. That is, what is the clause we are using here? We create this row. This is the data row which is displaying. What is this row? This row is this row. And how you find employee management system from the XML file is we use XSL colon value of select. So this is going to select the value by navigating to this XPath expression. That is, we are already under the project database. Under the project database, go to project node and then project name. So what it does, when you take a look at the XML file, we are already under the project database. It goes to the project node and then it takes the employee management system. Then it takes PHP and then it takes budget. So these are the XPath expressions, right? So we navigate to this. We navigate here, and then how you extract the value. For this, we have a syntax, that is XSLT. The syntax is XSL value of select. So it takes, it goes to this place on the file, navigates, and then takes the value. What is the value here? The value is employee management system. Likewise, it goes to this XPath location on the file, and then value of select will select PHP. Likewise, budget is selected and displayed as 1000, and we are also closing the HTML table. So what is that we are achieving here is our XSL file is ready, and this file will be binded to our XML file. How it is binded? You can see here, there's an href project.xsl. So whenever we are viewing this XML file, this style sheet will come into place, and then we'll get an output like this. So without this file, what will happen? If you don't have an XSL file, you'll get a plain XML output as I've shown you earlier. Maybe I'll try and run this code. I just show you. I have run some XSL code in the output. So you can very well see here. So this is project.xml, and you also have project.xsl created here. The only thing is we should be binding this XSL file with our XML. That is very important. See here, we have not binded that. So let me copy the binding code. Say how you bind that is, I have this, yeah, this is how you bind. So we give href. So let me bind this code here. So once when you have binded that, so this is the XSL file which I have created. I have binded that to XML, and I can very well view the XML file in the browser now. So project.xml. So you see we are getting the output as an HTML table. And where is this HTML table and things are defined? It is defined in the XSL file. So first you define the HTML table layout. And wherever you want to insert data, we use value of select. We then give the XPath expression here. So this is actually for an if-else statement, which we'll be looking up soon. But we have to give the XPath expressions, and then we'll be getting the output. So we'll be able to transform an XML file into an HTML page by using .xsl. Now we'll see the various other clauses before winding up this session. I know you may be a little tired after hearing all these concepts at once. So let's move forward. See, this is very simple, and if you spend some time, you'll be able to understand this. So for each class, say in our earlier demonstration, what we have done is, that is, what is the output here? We are just going to one node, printing the data from one node. So when you take a look at this, we are just printing employee management, PHP, and 10,000 in our table. But we want to print, we should be printing this data for all the project nodes. then what is that we should do? We should what is that we are supposed to do is we should run a for each loop for all the projects here, print the project name, domain and budget. So we have a for each clause in XSLT. So we have a for each clause which will run through every node and then take all that info we wanted, right? So the output will be like this, because for every project node we'll be printing project name, domain and budget. And how for each class works with our XSLT file is I given that here. So this HTML table code is the same, and you have this XPath navigation command, that is we start with the root node, and then here is the for each class. This is XSLT. For each select is equal to project. Now for each project, that is the clause here, for each select is equal to project. So what happens now is we'll navigate to project database, and what is that we are giving here? Project. So it's slash project. So for each project, what we'll do is we'll take the project name, project domain, budget, and then we'll put that as the data row. And then we'll be closing the for each element that we have opened. So when you use for each, what it does is for every project, it's going to take up the project name, domain and budget and then print it. If you're not going to use a for each, what will happen? It'll just print for the first node and then it will exit. So for each is used for traversing through a set of nodes, finding the value as per the XPath expression we are giving, and then printing the data to the HTML file. I mean printing the data to the HTML output. So when you talk about for each, this is the syntax: for each select the node, and then what are the sub elements we are selecting from that node, and we embed everything inside an HTML table. Finally, we close our for each tag. So that is the use of for each class. And I put up all the files on codespindle.com. You can just take the XML file, XSD file, XSL file, and you can see to that the bindings are there, and then you can run these files and you'll be able to get the output. Sort by domain name. Say I want to sort the output based on the domain. Say it is sorted in the ascending order here. So how to sort? So for this we have a class in XSLT that is given here. So we are going to run through every project node and display. Here you see we are displaying all the project nodes, so we need a for each class. So a for each class, so we are in slash project database slash project, and for each project we are selecting the project name and domain. Not only that, we are also sorting based on the project domain. So we say XSL sort select is equal to project domain. So what it does, this one goes through every project node. Say it goes through every project node, brings the project name and domain, and the clause we have used is sorting using the project domain. So it's sorted in the ascending order. So that is sorting. And before we wind up, we'll take up this final clause, that is if condition. Say we can also use if conditions, and if that condition is met, we can display that data out to the user. Say here I am displaying only data pertaining to the domain PHP. If the project domain is PHP, then include that in the output table. How did we achieve this? So everything else remains the same. This is the HTML table and closing the table, and we run through every project node. We use a for each and we check if test is equal to project domain is equal to PHP. So in our file, if project domain is equal to PHP, if this criteria is met, then you include project name and project domain in our data row. So if condition, say if test is equal to, so this is the keyword, is equal to project domain from is the name of the element in our XML file, is equal to PHP is the value that this project domain should satisfy. And finally you're going to get only those projects whose project domain is PHP. This is the output I have received, and this is the code which I have showed you just now, right? So you see project domain to be PHP, and you see this is the if test is equal to project domain equal to PHP. So I'm just getting project domain only project that has this specific domain. If I remove this, say when you remove the open tag, you should also remove the closing tag. That's important. And save this file. Now when I remove the if else condition and refresh my file, you see I'm getting all the projects. But when I have that condition, I'll get only projects pertaining to PHP. So what is that we understand here is by using XSLT, you can transform your XML file to any other file that you wanted to. And we have seen how to use the various clauses for selecting a value, or using a for each clause to select multiple values across nodes, or use sorting for sorting based on a specific value, or we can also use if else conditions to check only values that satisfy the condition will be displayed on the page. A lot of concepts, and we have finished looking at all these concepts very quickly. So what all we have learned, we have looked at what is XML, what is the use of XML, and what is the structure of an XML file, how it looks like, and what are the rules pertaining to naming XML elements. And then we moved on to the concepts on XML schema, the use of it. And then we looked at how to create an XML schema, how to validate an XML file against an XML schema. We looked at XPath, the various expressions that we can use in XPath to navigate an XML file. And then we have seen what is this extensible style sheet transformation, wherein we can use XPath to navigate through a file, and then we can convert that file to an HTML page by using the various clauses of XSLT. What are the clauses we have seen? We have seen the value of select value of, we have seen for each, we have seen the sort, we have seen the if else test condition. I hope you all had a good insight on what these concepts are all about. And that's it for this session. Thank you all for listening. Take care. And of course, don't forget to leave your comments below. Thank you.